My name's Luke Jones, and I work as part of the CAMS project, in which we make daily forecasts of and historic reanalyses of atmospheric composition, such as pollution, dust, and greenhouse gases. And as part of that, we need to be able to verify our model outputs. And we have our own software to do that, but the main piece of software was only designed to output static image files, which are then navigated by a browser application which just displays them. And that means a run of the code spends a long time generating hundreds and hundreds of images, most of which never get looked at. And if the user wants to see a plot which hasn't been produced, they have to run the whole thing all over again. So what we wanted was to be able to output just the raw forecast and observation pairs and have the plots made dynamically in a more advanced browser application. And that's the challenge that these young graduate students from Istanbul have taken up. I think they're all aged either 18 or 19, am I right?
Yeah.
So it's very impressive they're willing and able to take on a challenge as complex as this. And yeah, now I'll hand you over to them.
Yeah, our challenge is basically the CAMS Verisualiser, and today I'll be presenting with Yavuz Arda. We also have a team member. She's currently not here, unfortunately. Firstly, we'll tell you a bit about what the CAMS Verisualiser is. And then explain much better how it differs from the current application, which has static plot images. And we'll then give an example of how it in practice differs. Then we'd like to show you our current application live with some example data, and shortly explain how it in general functions and talk a bit about the challenges we have had. At the end, we can also receive a few questions. So what is the CAMS Verisualiser then?
All right, the CAMS Verisualiser is actually a web application for plotting and comparing recreational data. You can verificate your model data and compare it with the actual observation data to see, for example, the bias of the model data and other metrics. The key point of our application, the current application, is to retrieve and plot the data dynamically from the data files in netcdf or other formats and plot them on demand.
So how does it then differ from what we have more specifically? So currently, all possible combinations you'd like to verify are predefined. These are usually monthly or triple monthly data sets with models which have been matched before to be able to be compared. But with our CAMS Verisualiser, it's possible to just give the raw model data and the selection of time, months or dates, as well as models and their if they and comparison of them can be done totally dynamically. In the current application, you can select a few individual sites or a few groups like continental groups to get their raw data. We have expanded upon this greatly. You can in CAMS Verisualiser plot any kind of plot supported whilst selecting single sites, multiple sites, a few sites you like, or groups just like before, as well as individual dates these models were run at. So it has become much more flexible. And currently, in the application before, it was pretty hard to add anything new or like any new method or any new plot type, as this would require you to generate a bunch of images for whatever data you have, or you'll be limited to adding only new plots. Currently, it is practically trivial if they use this format of having an index and values, which is the only way to show our data currently. What I mean by that is, for example, plotting the data against valid time or sites and so on, instead of, for example, showing it against two different dimensions, which would be a bit more complex. But still, this could be modified in the future to add these if required, which would be much more work to do in the application before, I'm sure. So let's show a practical example. On the left, you see an image from the current application. And on the right, you see its equivalent in the current CAMS Verisualiser, our web app. As you can see, I mean, there are some small differences, but in general, the idea is the same, and basically, it looks quite similar. But what you can do currently is to easily, for example, change its color, or if you'd like to, as the data and plotting are actually completely separate in our application, you could also plot it in something else than the current library we are using, which is Plotly. Here I have plotted using matplotlib as a 3D plot, like a geographical plot. I mean, theoretically, it would be possible to plot it however you would like, just like the 3D plot you are able to see.
Also, this is a general diagram of the communications of the apps. The user interacts with web application. At the startup, the starting data and availability requests manage the options you can select as to let you choose only the selectable options, the options that there are data existing for. Also, we basically have a file system where all NetCDF files are. The Python plotting and availability API then parses them and gets the available data. Also, we have a script that writes those in an availability database, but here it's shown as unimplemented because we initially planned to make a separate SQL database, but it is currently in its entirety in Python. That is a thing to improve. Also, when you choose all the things you want in your plot, you make a request to the API and you get the data for the plot you like. This separation of the front end, the web application, and the API is especially good for if another front end will be used in the future, or even a command line interface.
An idea we had, for example, was to have some kind of also a Python application for showing these, like I believe the one before. So currently, it's very much possible to implement that. As you have the data, you just need to be able to show it in some application. So now we'd like to show how it looks.
Let me share the application. So the current application looks like this. You can select the data you want, the months you want, and the parameters. For example, I want a valid time graph for all these mounts with excess the X bias.
I believe
Also,
you've selected two of the same somehow Yavuz mounts.
okay. Oh yeah, I'm seeing. Also, I can get the graph of operational 21 when I press plot. I think I can also get the plot of this, and if I want them combined, I can also get that. Like this, you can turn them on and off in the plotly. It is also possible to get a map plot of the data like this with color scaling with the bias value and the size scaling with the sample size. You can zoom in and move however you want. And another thing we have is the two-dimensional histogram. You can get the comparisons like this, and it's all dynamic, and it is all being processed on demand with request to the backend API.
In real time, pretty much.
Yeah.
So something like I'd like to add. So as you can see, our UI is somewhat unfinished, and we'd like to elaborate a bit on why that is. Right now, can you see this?
Yeah.
Okay. So, so considering also that we have just graduated from high school, basically, the biggest problem we had was that we were quite inexperienced with any project, really. Also, a project of this scope, I would say. So, I believe we are a very capable team, but as we need to learn pretty much everything on the go, it all took a while to actually do this. And so another thing, this is especially relevant for the backend, is that we need to firstly understand the data, and then understand what we need to do with the data, and only afterwards could we plan how to get the plots we would like. So we also needed to standardize it to be able to make it work fast enough with such a web application, as the user would like to see the plots as fast as possible, of course. And if it takes, I don't know, many seconds for a plot to arrive, that might not be useful at all to a user. These were definitely very big challenges on the backend. And
This ever-changing backend also affected the front-end development for us. We wanted to make a standardized API request for the data, but we didn't quite grasp how the data will actually be standardized and how the finished structure will look until much later into our project. So with every update on the backend, something in the API broke, and also we wanted to make something that can dynamically generate from the netcdf files, but it was not actually initially the goal of the challenge?
It wasn't a requirement to better say. So basically,
Yeah.
maybe Luke can confirm us on this. Basically, what we needed to do was to show the maybe also pre-generative data, but it's totally currently done on the go pretty much from the start to the end, and I believe that was unrequired.
Also, we, like I said, we didn't understand what the finished product should be and will be until much later into our project. And that all made the front end still very challenging because I didn't know what the user should input for the backend to work essentially.
And this is much to do with our inexperience as well, because we also basically didn't know what we didn't know, so we also couldn't ask for it. So thank you for listening. We'll be happy to take your questions.